Wave interference is a phenomenon that occurs when two or more waves meet at the same point in space and overlap with each other. Depending on the relative phases of the waves, interference can result in the reinforcement, constructive interference, or cancellation, destructive interference, of the waves, leading to changes in the overall amplitude of the resulting wave at that point. To observe wave interference in experiments, you can perform the following demonstrations. Double-slit experiment. Set up a light source, such as a laser, and shine it through a barrier with two narrow slits. The light passing through the slits will form two coherent sources of light waves. Place a screen behind the slits to observe the interference pattern formed by the overlapping waves. You will see alternating bright and dark fringes on the screen due to constructive and destructive interference, respectively. Ripple tank experiment. Fill a shallow tank with water and create waves by oscillating a paddle or by dripping water from a small height. Place a barrier with two openings in the tank to create two coherent sources of waves. Observe the interference pattern formed on the surface of the water as the waves from the two openings overlap. You will see regions of constructive interference where the waves reinforce each other and regions of destructive interference where the waves cancel each other out. Michelson interferometer. Set up a Michelson interferometer, which consists of a beam splitter, two mirrors, and a detector. Split a coherent light beam into two paths using the beam splitter and direct the beams towards the mirrors. The beams will reflect off the mirrors and recombine at the beam splitter, interfering with each other. By adjusting the path lengths of the two beams, you can observe changes in the interference pattern at the detector, demonstrating the effect of interference. Young's double-slit experiment. Set up a light source, such as a laser, and shine it through a barrier with two narrow slits, similar to the double-slit experiment. Place a screen behind the slits to observe the interference pattern formed by the overlapping light waves. Gradually move one of the slits or adjust the relative phases of the waves to observe changes in the interference pattern, demonstrating the effect of interference. These experiments allow you to observe wave interference directly and provide visual evidence of the principles underlying the phenomenon. By studying interference patterns in different setups, you can gain a deeper understanding of wave behavior and the wave nature of light and other types of waves.